Okay. Next, what we can do is we can say, okay, now what we're going to do is try and solve for K. K is the diagonal number, so we got to pay extra careful attention to it. All right, so we want to try and find a moment where we can solve for K. And I think a good moment for that is going to be 6 because K isn't touching it. And it's nice that it gets rid of L for us. That's one less thing to worry about. So let's do the sum of the moments around 6 is equal to 0. And I can say that counterclockwise is positive. And I can say, okay, what are the forces we've got here? Well, first let's look at K. I know that it's going to be K, so I can say K times. Now let's see what is the distance from K to 6 perpendicularly. Well, this part's a little tricky. So let's look at the triangle. Let's redraw this. This is K. This is L. And this is I. And we're looking at distances right now. So what I gotta find, well, I know this is 60, and this is 30. What I gotta find is the distance. Here's 1.6. I gotta find the distance perpendicular to K. So I gotta find like that distance because that distance is perpendicular to K. Like that. So what makes this tricky is that before, when it was a 45, 45, 90 triangle, we could just say, okay, this side is K over 2. We can't do that anymore because it's not going to be evenly split, but it's okay. We can still solve for it. I'm going to redraw this triangle, redraw the triangle again, and I'm going to say, just looking at this is I, this is 30, so this must be 60, and I need to solve for X. Okay, so now to solve for X, let's just think about the trigonometric functions, and let's say SOHCAHTOA. So I'm going to say sine is opposite over hypotenuse. So let's say sine 30 degrees. Sine 30 degrees is equal to the opposite X over the hypotenuse I. Then I can say times I, and X is going to be equal to I times sine. Okay. Well, fortunately, we know what um we know what I is because we found it up here. We found this length, and that's what I is going to be. So I can come down here and say, okay, X is equal to 8.66 feet times sine 30. X is equal to 4.33 feet. Okay, so now we know this distance that we're going to multiply times k. That's the distance that k is away from 0.6 perpendicular to k. So k times 4.33 feet. And for now, I'm just going to assume k is positive, just as a default. Next, let's see what else there's going to be. Well, we're rotating around 6. We don't have to deal with L because it's touching 0.6. We do have to deal with J. So plus, and then J times, and the distance from J to 0.6 perpendicular to J is going to be this 8.66 times 8.66. And we know actually J is going this way right now to the left. So that would create, rotating around 0.6, that would create a counterclockwise rotation. So that would be a positive moment. So we can leave J positive. Next, let's see, do I include the 6 kips? No, because it's pointed right at 0.6. If I extended it, it would run right through 0.6. So distance is 0, moment is 0. Next, there's the 2 kips. Plus 2 kips. That's going to be positive 2 kips because by rotating around 6, it's creating a counterclockwise rotation times, or extend 2 kips down here, it would run through 0.4. So I know the distance is going to be 5 feet. I can problem. Next, there's 4 kips. 4 kips is in the same direction as 2 kips, so it's also going to be positive. 4 kips times, and it's going to be 5 feet plus 5. But if you extend 4 kips down, it's going to be 5 feet plus 5 feet away from 6. 4 kips times 10 feet. Then there's the reaction force. Plus RA, which is 15 kips, times, if I extend it up, it goes through 0.4, and then that is 5 feet away from 6. 5 feet. But wait, the 15 kips is going in the opposite direction of the 2 kips and the 4 kips. So, and those were positive. So this must be negative. It's creating a negative moment. It's creating a clockwise rotation. Okay, any other forces? No, I think that's it. Now we can start solving for K. 0 is equal to K times 4.33 plus J times 8.66. So that's 4.62 times 8.66. That's 40 feet plus 10 kip feet plus 40 kip feet minus 75 kip feet. 0 is equal to K times 4.33 feet. And let's see, we got 40 plus 10 is 50. Plus 40 is 90, minus 75. That's going to be overall plus 15 kip feet. Let me just double check that. 40 plus 10 plus 40 minus 75. Yeah, 15. Okay, I can see a minus 15. 15. K times 4.33 feet is equal to 15 kip feet. Divide by 4.33. Divide by 4.33. K is equal to 15 divided by 4.33 is equal to 3.46. 6. Okay. So that is K. And then what I want to do is I want to think about the direction. Wait a second. look here. Uh, I did -15 and -15, but I wrote +15 over here, so I gotta change that. -15, -3.46. So I got a negative answer for K, which means that my assumption was incorrect. I assumed that K was positive, creating a positive moment, but that was wrong. So it must be creating a negative moment. K is creating a negative moment around 0.6. Well, a negative moment means a clockwise rotation. So I got to be rotating clockwise around 0.6. And that would mean that K is going this way. Arrow one there. And I can say, okay, K is going away from the point, 0.5. It's away from the point. So that means that K must be in tension. Okay, that is that. Um, that's just a quick review on what to do, how to do the section method and the joints method. If the truss has like different angles other than 45 degrees. I hope this was helpful. Let me know if you have any questions.